Today we study periodic classification of elements. Doberiner's triads. In the year 1817 a German scientist Doberiner suggested that properties of elements are related to their atomic masses. He made groups of 3 elements each, having similar chemical properties and called them triads. He arranged the 3 elements in a triad in an increasing order of atomic mass and showed that the atomic mass of the middle element was approximately equal to the mean of the atomic masses of the other 2 elements. However, all the known elements could not be classified into the Doberiner's triads. Newland's law of octaves. The English scientist John Newlands correlated the atomic masses of elements to their properties in a different way. In the year 1866 Newlands arranged the elements known at that time in an increasing order of their atomic masses. It started with the lightest element hydrogen and ended up with thorium. He found that every 8th element had properties similar to those of the first. For example, sodium is the 8th element from lithium and both have similar properties. Also, magnesium shows similarity to beryllium and chlorine shows similarity with fluorine. Newlands compared the similarity with the octaves in music. He called the similarity observed in the 8th and the 1st element as the law of octaves. Many limitations were found in Newland's octaves. This law was found to be applicable only up to calcium. Newlands fitted all the known elements in a table of 7 into 8, that is 56 boxes. Newlands placed 2 elements each in some boxes to accommodate all the known elements in the table. For example, copper and nickel, cerium and lanthanum. Moreover, he placed some elements with different properties under the same note in the octave. For example, Newlands placed the metals copper and nickel under the note Do along with halogens, while iron, having similarity with copper and nickel, away from them along with the nonmetals O and S under the note Ti. Also, Newland's octaves did not have provision to accommodate the newly discovered elements. The properties of the new elements discovered later on did not fit in the Newland's law of octave. Mendeleev's periodic table. The Russian scientist Dmitry Mendeleev developed the periodic table of elements during the period 1869 to 1872 AD. Mendeleev's periodic table is the most important step in the classification of elements. Mendeleev considered the fundamental property of elements, namely, the atomic mass, as standard, and arranged 63 elements known at that time in an increasing order of their atomic masses. Then he transformed this into the periodic table of elements in accordance with the physical and chemical properties of these elements. The vertical columns in the Mendeleev's periodic table are called groups while the horizontal rows are called periods. Merits of Mendeleev's periodic table. First, atomic masses of some elements were revised so as to give them proper place in the periodic table in accordance with their properties. For example, the previously determined atomic mass of beryllium, 14.09, was changed to the correct value 9.4, and beryllium was placed before boron. Second, Mendeleev kept vacant places in the periodic table for elements not discovered till then. 3 of these unknown elements were given the names EKA boron, EKA aluminium, and EKA silicon from the known neighbors, and their atomic masses were indicated as 44, 68 and 72, respectively. Not only this, but their properties were also predicted. Later on these elements were discovered and named as scandium, Sc, gallium, Ga, and germanium, Ge, respectively. The properties of these elements matched well with those predicted by Mendeleev. See Table 2.4. Due to this success, all were convinced about the importance of Mendeleev's periodic table, and this method of classification of elements was accepted immediately. There was no place reserved for noble gases in Mendeleev's original periodic table. However, when noble gases such as helium, neon, and argon were discovered towards the end of 19th century, Mendeleev created the zero group without disturbing the original periodic table in which the noble gases were fitted very well. Demerits of Mendeleev's periodic table. First, the whole number atomic mass of the elements cobalt, Co, and nickel, Ni, is the same. Therefore there was an ambiguity regarding their sequence in Mendeleev's periodic table. Second, isotopes were discovered long time after Mendeleev put forth the periodic table. As isotopes have the same chemical properties but different atomic masses, a challenge was posed in placing them in Mendeleev's periodic table. Third, when elements are arranged in an increasing order of atomic masses, the rise in atomic mass does not appear to be uniform. It was not possible, therefore, to predict how many elements could be discovered between two heavy elements. Fourth, position of hydrogen. Hydrogen shows similarity with halogens, group 7. For example, the molecular formula of hydrogen is H2 while the molecular formulae of fluorine and chlorine are F2 and Cl2, respectively. In the same way, there is a similarity in the chemical properties of hydrogen and alkali metals, group I. There is a similarity in the molecular formulae of the compounds of hydrogen alkali metals, Na, K, etc., formed with chlorine and oxygen. On considering the above properties, it cannot be decided whether the correct position of hydrogen is in the group of alkali metals, group I, or in the group of halogens. Modern periodic law. Periodic table. It is the table of chemical elements arranged in order of atomic number such that elements with similar atomic structure appear in the vertical columns. Modern periodic law. The modern periodic law states the chemical and physical properties of elements are a periodic function of their atomic numbers. Structure of modern periodic table. In the modern periodic table, the elements are arranged in the order of their increasing atomic number. In the modern periodic table there are 7 horizontal rows called periods and 18 vertical columns, 1 to 18, called groups. The arrangement of the periods and groups results into formation of boxes. The 4 blocks are S, P, D, and F. Elements in each block are color-coded in the background graphics, the periodic tables, and the element pages themselves. Modern periodic table and electronic configuration of elements. Within a period the neighboring elements differ slightly in their properties while distant elements differ widely in their properties. Elements in the same group show similarity and gradation in their properties. These characteristics of the groups and periods in the modern periodic table are because of the electronic configuration of the elements. It is the electronic configuration of an element which decides the group and the period in which it is to be placed. While moving from left to right in a period, only electrons in the same shell increases, but in a group number of shells increases from top to bottom. The transition elements are in the d block, and in the d orbital have valence electrons. They can form several states of oxidation and contain different ions. Inner transition elements are in the f block, and in the f orbital have valence electrons. They are the lanthanides, and the actinides. The halogens are a group in the periodic table consisting of 5 chemically related elements: fluorine, chlorine, bromine, iodine.